Hello my dear students, good afternoon. Today we will discuss about a few more preparations of aldehydes and ketones. In that for today, first one by the distillation, dry distillation of calcium salts actually we will discuss. Distillation means heating of those particular calcium salts in presence of water. Okay, that happens. So what happens here, let's see. Suppose I am taking HCOO, that means what you can write, calcium salts I have to take. So I am taking this Ca and C double bond OH. This is called HCOO twice actually. HCOO twice Ca. Okay, and HCOO is HCA and C double bond O and OH here and C double bond OH here. So HCOO twice Ca. So simply this reaction we will take like this, HCOO twice Ca. Getting what I am saying? HCOO twice Ca when you are taking on like this on arrow, if they given dry distillation if they given on arrow, what to do means HCOO twice you have no? So here write down C double bond O like this, because aldehyde or ketone you have. So here HCOO twice only they given 2 times like this, or they won't give 2. That means what will come? Okay, HCOO twice only given calcium formate. What is this? Calcium formate. If they given calcium formate, 2 moles even they not given, we have to take 2 moles, because this dry distillation takes place between 2 salts of calcium. Okay, calcium salts of carboxylic acids actually. Why carboxylic? COO. Understanding? So calcium formate, this is 2 moles. So here first write down C double bond. Here for this COO, who attached? Hydrogen attached? Write down both sides hydrogen. That is the aldehyde you are having. That's it. So HCOH and CaCO3. Calcium carbonate is the product. Okay, 2 moles. So 2 times you will have 2 times of CaCO3 like this. Understanding? So that is not required. So here what group you have? Hydrogen you have. So both sides hydrogen. Suppose like this given RCOO whole twice Ca, this on dry distillation if they given, what is the product means? First you write down C double bond O. Understanding? First you write down C double bond O. And here what is the alkyl group you have? R. Okay, so here both sides R you write down. So ketone you are having. Simple way. Understanding? So 2 moles of calcium formate when they reacted, and you are having like this. Okay. So actually calcium formate now. So sorry. So this I have to write like this, H and C double bond O. Okay. So here also H and C double bond O like this. HCOO twice Ca. I written here same manner. This is correct only. Absolutely correct. And here also same manner. So C double bond here, H C double bond O, and here also same story, H C double bond O like this. So remember these in this manner only. So on dry distillation what happens means, so as I told you, see this HCOO like this. What happens here? H C double bond OH. So H C double bond OH you have. One more. Correct? So again, so now from here, so H from here, C double bond OH from here. So H C double bond OH. So one more mole you are having. So H C double bond OH you are having. Remaining is what? C CaCO3 you are having. Correct? Here also CaCO3. So 2 moles of CaCO3 you are having. See, this is the simple way how to remember this reaction I was given here. but here I shown how aldehyde was formed. So HC double bond O, H you are having, and HC double bond O, H you are having. Calcium formate, previously I written wrong, so now I written correctly here. So HC double bond OH and HC double bond OH you are having. Got it, sir, clearly? So this is about the dry distillation of calcium salts. So with the same kind I was given HCOO twice Ca, so calcium formate. So this one is general I was given. So R I was given. So calcium alkanoate. If it is methyl, calcium acetate you can say. Calcium acetate. So can I write those reactions? So you please write down this reaction. First this is completely one reaction, or else I shown here. How to remember, understood? So you are preparing aldehydes. So C double bond O pakka. So here what group you have? Hydrogen. So hydrogen 2 times. Here only one kind given. Only one kind. 2 moles they will not give. Suppose. So they was not given suppose. But you have the 2 moles here. Understanding? So okay. Only one type of calcium salt given. Okay. C double bond O. Here what group you have? R. So both sides R. Instead of R, here Giri sitting. So both sides Giri, that's it. Here some methyl is there instead of R, some methyl is there. Both sides methyl, that's it. Understanding? In that way we have to consider. Have a screenshot and write down. Okay. So now I'll give you one more type of reaction actually. So okay, in this only. So learn slowly, no problem. But you must know this aldehydes and ketones properly. So as I mentioned, so syllabus is not a problem, understanding is a matter. Okay, so now here I am taking like this RCOO twice Ca plus HCOO twice Ca. So in previous both are same kind I was given, now I am giving different. One is calcium alkaloid, one is calcium formate. Now what is the product means? Same story. First you write down C double bond O. Now here what groups you have? Here for the COO what groups you have? For this COO what group you have? So here hydrogen you have and here R you have. Those you have, right? That's it. So R C double bond OH aldehydes, and same story as usual calcium carbonate you are having. Got it clearly? With the same kind of reaction I will give like this. CH3COO whole twice Ca. CH3COO I am giving. What I am giving here? CH3COO twice Ca plus HCOO twice Ca I am giving. Now on dry distillation, this is common, dry distillation. Dry distillation. What is the product here? Very simple. First you write down C double bond O. Okay. And what the group you have here? See, here you have a methyl group and here you have hydrogen group. So methyl and hydrogen. That means you have the product like this. CH3 and C double bond OH and 2 moles of CaCO3. Got it clearly? So instead of R, you have methyl. R means what? Alkyl. That alkyl is methyl here. That's it. Okay? So CH3COO twice Ca and HCOO twice Ca, and if they reacted and you are having aldehyde. Got it, sir, clearly? Suppose you have this CH3COO twice Ca plus and CH3 CH2 and COO, CH3 CH2 and COO twice Ca given. On dry distillation, what is the product? Okay, so what groups here you have? That's it, nothing more than that. And here you have a C double bond O. Got it? So here you have a methyl. Okay, here you have a ethyl. That's it. Understanding? Here what group you have? Methyl group. Here what group you have? Ethyl. C2H5. C2H5. 3 plus 2, 5. Understanding? So one side you have a methyl and another side is CH2, CH3, ethyl group. So butanone you are having product. Got it clearly? So I will write one more reaction. So you have to fill it. you have to write this, and C6H5 and C double bond O, COO whole twice. Understanding? Whole twice Ca and CH3 COO whole twice Ca on dry distillation. What is the product? You tell me. Okay, C6H5 is one group for COO. This is called COO. So this is COO, and here also you have COO. Just for understanding, C double bond O I written. So here what is the alkyl group? Phenyl. Here what is the alkyl group? Methyl. So for C double bond O, and you are having this C6H5 and one side is methyl. C6H5 is one side and methyl is another side, and 2 moles of CaCO3. I said you have to write, na? Okay, no problem. So I was written. Okay. So calcium benzoate it is. Calcium benzoate. Names why I am saying understanding. In question they will ask. On dry distillation of calcium benzoate and calcium acetate, the product is. Here I shown the reactants. So I was given one trick for C double bond O. Alkyl groups you write down over acid. But if they given names you must know. So what is the name of this? This is called calcium benzoate. You write down name. Okay, calcium benzoate and calcium acetate. Then the product is this one, ketone. Got it? So at least next one more I will give. This kind only. Please write down. Okay, write down means take a screenshot. Then you can write later on. Okay, so this only I will give like this now. C6H5 and COO whole twice Ca plus HCOO twice Ca. Then what is the product? On dry distillation, what is the product? Can you say what is the product here? So this is calcium benzoate. Okay, if you want I will write name. This is calcium benzoate and this is calcium formate. I written already. This one is calcium formate. Why formate understood? One carbon only there. So calcium benzoate, calcium formate. Very simple. Can I say? C double bond O you will write, and this is benzene ring one side, hydrogen one side. Then over in our product. So this is about dry distillation of calcium salts of carboxylic acid, and same next from decarboxylation of same carboxylic acids. Okay, so that we have to discuss. What's the next? Decarboxylation. Okay, decarboxylation of carboxylic acids. Very simple. Decarboxylation means removal of carbon dioxide. Removal of what? Carbon dioxide. That happens. Okay. So same story here also. If you take one kind HCOOH and HCOOH and 2 times and manganese oxide MnO 300 degrees Celsius, because heating is required now, because decarboxylation means what? Removal of carbon dioxide. Same story here also, you have COO and COO, but it is not a calcium salt, right? So same story, first you write down C double bond O here, got it? And hydrogen you write one side, and this hydrogen also you write another side, but here the remaining byproducts are H2O and CO2. That's it. Got it clearly? So here what I did, same I did COO. For that what group was attached? Hydrogen. For COO what group was attached? Hydrogen. So for CO I written hydrogen both sides. That's it. Then I can get product or not. So formic acid on heating with MnO. What acid it is called? This is called formic acid. Formic acid on reacting with MnO. Formic acid 2 moles like that they won't give. Formic acid on heating at 300 degrees Celsius. in presence of MnO, manganese oxide. Then what is the product means? Okay, only formic acid, sure. Then okay sir, in formic acid the group is okay HC double bond O OH. HC double bond O. So for C double bond O, what group is there? For C double bond, what group is there? Okay, HC double bond O, H is the product. Okay, so remaining is H2O and CO2. Suppose if I have one more means different one, like this acetic acid if I am taking CH3COOH 2 moles given, then in presence of manganese oxide at 300 degrees Celsius, what is the product? Okay, acetic acid, then the product is C double bond O. Okay, so here for COO, what group is there? Methyl. So move both sides methyl. CH3, C double bond O, CH3 plus H2O plus CO2. That's it. Over no? So very simple or not? Suppose different acids given like RC double bond O OH plus HC double bond O OH in presence of manganese oxide and 300 degrees Celsius. What is the product? Means very simple. For COO, what groups was attached here? One is alkyl group and one is hydrogen. So very simple. That means your product is R, C, double bond O and H. Get it? So for C double bond O, one alkyl group, one hydrogen. That's it. And remaining same story. That is H2O and CO2. Get it? Sir, different sir. Like R C double bond O OH plus R dash C double bond O OH. Two different types of acids was given at 300 degrees Celsius. Means what to do sir? Very simple. First you will write C double bond O and both sides. Same story. COO, COO. For that, what groups was attached? So here alkyl group R attached, here R dash attached. Both you will write here R as well as R dash. That's it. Over no product. And along with that H2O as well as carbon dioxide you are having. So understanding everyone. So here what you have means ketone you are having. Very simple. When you are having aldehyde, some carboxylic acid with formic acid, then you are having aldehyde. Both are having alkyl group only. See this is alkyl group and this is also alkyl group. Both acids have alkyl groups. Certainly here you have R and here you have R, means okay, ketones are product you can say. Why I am saying this? Which carboxylic acid on treating with manganese oxide at 300 degrees Celsius gives ketone? If they ask, they should not. They means carboxylic acid should not have formic acid. Getting what I am saying? If both are having some alkyl groups, certainly you are having ketone. If one is formic acid, if you have another also formic acid, or at least one is formic acid, you are having aldehydes. Getting clearly? So this is the formic acid and this is also formic acid, so formaldehyde. See here this one, if you see, this is some other carboxylic acid and this is formic acid. In presence of MnO, you are having RC double bond OH. Very simple. So in similar manner like this, if you have like this CH3, CH2, COOH given like this and plus HCOOH given and manganese oxide given, 300 degrees Celsius given. What is the product? Very simple. You are writing first C double bond because aldehydes are the products. So here for COO, what groups was attached? Here ethyl group attached, here hydrogen attached. So here ethyl group, that is CH3 and CH2 and H. Propanol is the product. What I did understood? Ethyl and in this formic acid H. So you are having propanol, CH3, CH2, CHO like this. Understood sir? So this is one more preparation of carbonyl compounds. Getting? So carbonyl compounds, how to prepare we discussed. So previously I think ozonolysis we discussed, and from alkynes on treating with H2O in presence of HgSO4 and H2SO4 we discussed, and from geminal dihalides we discussed, and today dry distillation as well as one more decarboxylation of carboxylic acids we discussed. And next hydroboration of alkynes. Hydroboration of what? Alkynes. Do you remember hydroboration of alkynes? It is by anti-Markovnikov rule. Do you remember anti-Markovnikov rule? It happens. Okay, addition of BH3. Hydroboration means what? Addition of BH3. Okay, and H minus and BH2 plus. Do you remember this? Hydrogen is more electronegative than boron. Okay, that's why it is BH2 plus and this is H minus. So addition of BH3 followed by hydrogen peroxide. Do you remember? So that one. But for alkynes, you remember or not? For alcohols preparation also same I was given. What is that? Alkenes, for that if you add BH3 and followed by H2O2 addition, then you are having alcohol by anti-Markovnikov rule. But here addition of BH3 for alkyne, first enol you will have and further converted to either aldehyde or ketone. But here hydroboration gives aldehydes only because anti-Markovnikov rule. Getting? Suppose if I am taking this one CH triple bond CH, or if you have some methyl here CH3C. Okay, CH3C triple bond CH. For this I am adding BH3. BH3 means what I said, H minus and BH2 plus, right? So if this migrate over here, this carbon gets positive charge and this carbon gets negative charge. Correct or wrong? Yes. Correct? Huh? So BH2 plus will add on here and H minus will add on here. Why this pi bond migrating over here? Here positive charge is secondary, which is more stable. Understanding everyone? So CH3C triple bond CH, for that I am adding BH3. This we did already for double bond. You can revise alcohols preparation once. Okay, so what you will have here, so CH3 and C and H here and double bond and here CH2 and BH2 like this. Correct or not? So this will form and this will react with how many times? 2 moles of CH3C triple bond CH can react or not, because 2 more hydrogens are there. Am I said this one? So what happens here? Understanding everyone? Hydrogen, this hydrogen was added here, and if you want with black color I will write this H and this one is BH2. Correct? So with boron there are 2 more hydrogens, means 2 more alkynes can react. I told for alkenes the same kind I said, but there double bond you have, so here you will have single bond, but here triple bond you have, so 1 bond migrated remaining 2 bonds. Slowly understand, not a problem. So what you will have here excuse me, CH3CH and double bond and CH2 whole thrice and B, whole thrice B here you have. Got it everyone? So what you will have now? So very simple. For this, if you add backside, I will write like this. Okay. Here I will write. Suppose if I am adding H2O2, then I told many times the OH here and OH here. Like that, how many times? 3 times. So 3 times OH and 3 times OH. 3 moles of H2O2. Because 3 moles of this alkynyl groups you have. Allyl groups otherwise. So what you are having here? CH3, therefore CH and double bond and CH2, and here you are having OH. Okay, 3 moles. What form this is called? This is called enol form. Enol form or not? So what happens next? This will come over here and this will migrate. Certainly your product is enol form, which is called, what that is called? Tautomerism. On tautomerism, this turns to CH3 and CH2, and I written more hydrogens here, right? So 1 hydrogen only, sorry, and here CH and CH, and therefore here you are having CH double bond O. Sorry sir, here CH BH2. Okay, so BH2 was added there. CH whole thrice. CH double bond here, so CHO, and this minus charge, so H plus will come over here. So CH3, CH2, CH double bond O. That means what it is? Aldehyde you are having. Aldehyde you are having or not? So this is hydroboration of alkynes. What you have here understood? So CH3, CH, double bond CH, OH you have. Why this found understood? So CH3, CH, double bond CH, BH2. So two more hydrogens, same story. Here hydrogen and B here. Same, 2 times will happen. Got it? So have a screenshot and write down. I'll give you one more. Okay sir? So addition of this BH2 only. So if I have this, what is the product? You fill this one, please. C6H5 and CH, or else okay, CH2 C triple bond CH. For this I was sorry, I am not adding, you have to add, and here BH3 given and H2O2 given. That's it. Okay, what happens? 3 moles was not given, don't say they won't give like that. Simply they will give this one and you have to say what is the final product. Okay sir, please do that. And what happens here? OH is adding finally at the terminal carbon or by anti-Markovnikov rule. First enol is forming and then you are having aldehyde. Okay, so this is about one more important preparation. Next, oxymercuration and demercuration of alkynes. Okay, next one is oxymercuration and demercuration. Demercuration. Do you remember? Oxymercuration and demercuration of alkynes. Please, you have to revise both hydroboration as well as this oxymercuration and demercuration of alkenes we done in previous for a preparation of alcohols. Now we are doing for what? For the preparation of aldehydes and ketones by using alkynes. By using what? Alkynes. So you remember, I think so, this is by Markovnikov rule. Correct? Huh? By what rule? Markovnikov rule. So very important. So same example I will take CH3C and triple bond CH, and oxymercuration means, correct? So I am writing both. See, for the same I was written BH3. So OH you have here. Now you have at middle carbon. So according to Markovnikov rule means with less number of hydrogens or not. So I am adding oxymercurating agent, that is HCO twice Hg. Okay, so this I am taking. Okay, and mercuric acetate, CH3COO twice mercuric acetate, CH3COO twice Hg, and demercurating agent, first one and the second one is NaBH4. Very simple addition of water only, do you remember? So OH minus will add to the unsaturated carbon which have less number of hydrogen. Mercury if you have and NaBH4 if you have on arrow. That means addition of water by Markovnikov rule, that's it. But selectively without rearrangement, I told. Surely, pakka I told. Without rearrangement this happens. So what happens here? See this CH3C triple bond CH if you add. So the product is CH3 and C and OH here and double bond CH2. What is the difference between that hydroboration and this? Hydroboration means CH3C triple bond CH when added BH3 and followed by H2O2 means you are having like this CH3 and CH double bond CH OH. See the difference? This is by Markovnikov rule and this is by anti-Markovnikov rule. Got it clearly? So this is about what exactly oxymercuration and demercuration. Correct, I said in previous addition of BH3 followed by H2O2 and OH you have, that means negative species, OH minus na. So negative species you have at unsaturated carbon which have more number of hydrogens. But here OH minus you have at unsaturated carbon which have less number of hydrogens. So here also a tautomeric product will form, not tautomeric. Okay, so CH2 here. Can you guess what happens here? So this will migrate over here and this will go back. Certainly our product is, after tautomerism, our product is CH3, C double bond O and single bond CH3. CH3, C double bond O, CH3. That means ketone you are having. But here what we are having, if this coming over here and this coming over here and CH3, CH2 and CH double bond O. See the interesting thing here, reactant is same in both cases and oxymercuration and demercuration gives ketone, acetone, and for the same reactant if you add BH3 and H2O2 you are having aldehyde CH3, CH2, CHO, propanol. What is this? Propanol, and this is propanone or acetone. Difference you must know everyone. So this is about oxymercuration and demercuration. So yesterday I told you oxidation of alcohols. Okay, so do you remember those? So this one you written already plus and you have write this please. Okay, so this is about oxymercuration and demercuration. Do you remember oxidation of alcohols by using mild oxidizing agents? Do you remember oxidation of alcohols by mild oxidizing agents gives what? Aldehydes or ketones. Correct? Mild oxidizing agents like what? Like PCC, PDC. I was given some examples of mild oxidizing agents as well as strong oxidizing agents in previous. So PCC, pyridinium chlorochromate and pyridinium dichromate, both examples you have in your book. Okay, so if you use, I was given very clearly primary alcohols on oxidation by PCC or PDC, the product is aldehyde. Product is what? Aldehyde. And the secondary alcohol by using this PCC or PDC and you are having ketone, that's it. I won't give more than this because in alcohols properties you have. If you use strong, these aldehydes converted to carboxylic acids, and in ketones also if you use strong and if difficult but CC bond will break with a less number of carbons, carboxylic acids will form. Ulta means reduction, aldehydes reduction into alcohols, ketones reduction into secondary alcohols. Even carboxylic acids on reduction, aldehydes on reduction, primary alcohols, like that. This is a stepwise step. Oxidation means alcohols into aldehydes into carboxylic acids. Reduction means ulta takes place. Carboxylic acids first converts to aldehydes and aldehydes converts to primary alcohols, like that. But here our discussion is about oxidation of alcohols. So primary alcohol, suppose I said I won't give example but simple example I will give, and CH3CH2OH if you are using this PCC or else PDC, pyridine dichromate, and your product is like CH3 and CH double bond O you are having. And if you taken some ketone, why or not required? If you taken some ketone here, ketone means like secondary alcohol if you taken, and CH3, CH and OH and CH3, and if I am taking the same this PCC or else PDC, you are having ketone. Okay, oxidation na, so plus H2O oxidation. Here one hydrogen, here one hydrogen. So here what happens? Same story. That is CH3, C double bond O, CH3. Ketone you are having. Secondary. This is primary because primary no OH attached to primary carbon. One carbon. This carbon attached to one carbon. this carbon attached to two carbons. So this one secondary. Okay, secondary gives ketone. Okay, same I was given, that is dehydrogenation. Do you remember dehydrogenation? Same story. Dehydrogenation means, what is dehydrogenation? If you use on arrow, if you use copper at 300 degrees Celsius, same story, copper at 300 degrees Celsius, but along with that H2 will come, that's it. Here H2O you have and here H2 will come, that's it. So that is called dehydrogenation. So those are also given. So few more preparations we have, and in our next class we will discuss those preparations. Till here to practice much more effectively so that you will have full clarity and confidence.